Hello and welcome to today's webinar entitled Discover Cube Land. My name is Colby Brown and I am the Director of Training and Technical Sales for City Labs in North America and the Americas generally. And I am joined today by Dr. Francisco Martinez, whom we're very lucky to have joining us. I'm not sure if his audio is connected yet. Dr. Francisco Martinez, are you there? Can you hear me? Okay, well, we may be joined by him later on if he has a chance to connect up the audio. Can everybody else hear me all right? Is there any difficulty hearing me? If anybody is having trouble hearing me, please, enter a question in the question pane or send a chat to let me know that you're having difficulty. Otherwise, we'll continue with our webinar. So first, I'd like to provide an overview and an agenda for today's presentation. CubeLand is an economic land use model designed for easy integration with our Cube Voyager travel demand forecasting software, as well as Esri ArcGIS. And this webinar will provide a general introduction to CubeLand, including the following topics. We will give a brief overview of integrated land use and transportation modeling, and especially how this kind of model is built using CubeLand. I'll give a brief demo of some interactive scenario evaluation using our standard demonstration materials, and then I'll talk about some updates we made to CubeLand for the most recent release, version 5.1 of the software, and I'll discuss a few case studies and applications. And hopefully we'll have some time for question and answer at the end of the webinar. So if you have any questions about CubeLand or our software generally, or any of the applications I mentioned, feel free to type them into the question pane during the webinar, and we'll read through them after we're done with the presentation and provide you with answers to all of your questions. So without any further ado, I'd like to first start out with a description of the motivation as we see it for integrated urban modeling, meaning modeling land use and transportation at the same time. Most models currently are so-called four-step travel demand forecasting models, which correctly recognize that trips are generated by separation of land use and socioeconomic activities, by which we mean households and firms. So the idea is pretty simple. Basically, land use, or different patterns of land use, or buildings, ways of using land, zoning patterns, etc., give rise to the locations of households and employment, or jobs and firms. And the separation of households and employment and jobs and businesses gives rise to trips in between different households, in between households and their place of work, or in between businesses. And this is what we call travel demand. So the standard travel demand forecasting process is this one-directional flow that we see here on the current slide. However, households and firms also logically seek accessibility, meaning access to the destinations they most desire to travel to, and avoid congestion when they make location decisions. This is a fairly intuitive principle, and it's long been recognized in the transportation and land use planning field. It's been considered in some early models. This is not a new idea. Dating back to almost the beginning of computerized transportation and planning models, we've had some recognition of this. Lowry was one of the first in 1964 in Pittsburgh. And basically, the idea is that we create a feedback loop from the travel demand side back to land use, which translates congestion and accessibility measures into behavioral responses to new land uses and new locations of households and employment. So it's really a pretty simple idea, just that we should have forecasts that are based upon consistent assumptions in terms of land use and travel demand, and build in or include some representation of the response households and firms will have to congestion and accessibility effects. So some of the benefits of this kind of approach are listed on this slide. First of all, this kind of model yields better transportation planning, and the key here is consistency between the land use assumptions and the travel forecasts. If you have land use assumptions that give rise to enormous amounts of congestion that would clearly be inconsistent with the land use assumptions you started with in the first place, this kind of invalidates the whole forecast. So having a model that reconciles the land use assumptions with the congestion and accessibility output by the transportation model does lead to better planning. It also is a way of producing more accurate forecasts. Whether or not we agree with planning decisions, when it comes down to designing a facility, the facility will work better if it's designed with better forecasts that take into account the future development or lack thereof that's likely to occur in the corridor or the market area for a transportation facility. So there are lots of benefits for transportation planning and even design coming out of the use of these kinds of models. It also has a lot of benefits for land use planners who are engaged with the detailed day-to-day decisions regarding how land and economic development policies play out in urban areas. And we can make better decisions informed by an understanding of how traffic and transit improvements will affect development in the future with real economic measures as to how these things work. And these models can provide tools that allow you to assess the effectiveness of some of these policies and incentives with an eye to interactions with the transportation system. So we can look at transportation side approaches to modifying our urban landscape. And in general, for both transportation planners and land use planners, regardless of your focus or whether you're doing both things at the same time, these kinds of models yield more coordinated planning efforts with a common set of assumptions and tools that enable new kinds of analyses and offer new kinds of performance measures even to address one of the key buzzwords we have these days, which is sustainability. And I'll talk a little bit more about that going forward. So if this idea has been around for so long and it's offered so many benefits to our agencies and consulting planners, why isn't it a more predominant aspect of our land use and transportation planning practice today? Well, to be fair, probably about a third to a half have some of this, but maybe not a fully integrated model. And historically, some of the challenges have been things like data availability. And really, this is starting to get addressed by the fact that we have new census programs now, at least in the U.S., such as the Longitudinal Employer Household Dynamics Program, that offer better data on these dynamics and more detailed estimates of where jobs and households are located within our urban regions on a more frequently updated basis than we've had access to previously. So that's a fairly recent change. Within the past 5 years or so have those data sets become really well known and understood. We also have commercially available data sets that can also fill in the picture, and some of these have become much more well known over the past 5 to 10 years as well. Finally, the rise of GIS has given rise in turn to a wealth of land use and transportation data that are now stored in geographic data sets. This is one of the big reasons why Cube is so tightly integrated with Esri ArcGIS, because it provides our users and model builders with access to all these rich data sets, including digital parcel layers, which are generally widely available at most planning organizations in the U.S. and increasingly available throughout the world as well. We also see some policy and regulatory shifts that may change priorities and drive more focus towards this kind of planning using more technical analysis and forecasting. We see a renewed focus on sustainability and livability in addition to the old priorities on mobility, safety, and other issues such as accessibility. We also see individual states, aside from federal levels of government, states and provinces are moving, in some cases, ahead of their own countries and really setting leadership in state legislation that addresses sustainability and livability. And we're starting to see partnerships between land use planning agencies and departments of transportation, some of which have been already established throughout other parts of the world. But in the U.S., this is a very big innovation. And we certainly see lots of opportunities for new kinds of planning resulting from these policy and regulatory shifts. And finally, one of the biggest things that's changed, and that's what I'm going to spend most of my presentation talking about, is the affordability and ease of use of these models. In the past, there's not been a lot of commercial off-the-shelf software of high quality available to address the need for integrated land use and transportation forecast modeling. Whereas today, what I'd like to talk to you about is one such software package, CubeLand, that we've developed that is commercially available off-the-shelf software, meaning that you don't have to go out and hire a consultant to program something custom for just your region. And it really brings down the cost and increases the affordability and ease of use of integrated land use and transportation modeling. So this brings us to CubeLand. CubeLand is economic land use modeling software designed especially for interaction with transportation planning models. It's based upon the MUSA 2 framework, which was developed by Dr. Francisco Martinez and fellow researchers at the University of Chile. And it's been applied to studies of land use and transportation policy in Santiago. I'll take a moment later on, of course, to talk about those studies when we get to our case study section of this presentation. And City Labs has entered into a unique agreement with Dr. Francisco Martinez, which allows us to distribute CubeLand as a library coupled with the powerful cube-based interface for modeling in GIS. So we're really taking one of the most widely acclaimed and peer-reviewed, by the way, econometric models of land use and giving it a really intuitive and easy-to-use user interface that's directly tied into the transportation forecast modeling framework we sell. And this is a pretty new development. It's been sort of really coming into full force over the past couple of years, and we're very excited about this opportunity. Dr. Martinez, are you there? Not sure were you able to connect up your audio? Okay. Still can't seem to hear Dr. Martinez, so I'm not sure if his audio is connected, but perhaps we'll hear from him later on a little bit about some of the research that led up to the development of MUSA. In the meantime, I'll sort of give an overview of the underlying framework, which includes a lot of explicit representation of economic behavior. There's a lot of solid economic grounding and really well understood theory behind this. Okay, so Francisco says he's here, but I don't hear him, so I'm not sure what the cause of that is. We'll try to work it out as we go on. In general, inside CubeLand, we are computing a real estate market equilibrium between real estate supply, represented by the behavior of developers and landlords, and demand, represented by the location behavior of households and firms. And this is a bid-rent type model that has clear economic logic and interpretation. The idea is that real estate properties are occupied by the household or firm willing and able to pay the most. And developers choose to maximize profits when deciding what type of buildings or land use or real estate to provide. This is all subject, of course, to bounds, constraints, restrictions, and policy assumptions, meaning that we can program into the model fixed development and institutional uses, meaning that if we're in a capital city of a large region, for example, the state capital is not likely to move locations because it's been there for, let's say, 50 years and it's not going to move. We can also program in limits on growth and redevelopment. We can include policies such as taxes, subsidies, and zoning rules about what kind of land uses may occur in which locations. And we can include or treat exogenously, rather, vacant uses and undeveloped land, meaning we can take some land and just say this is not going to be developed or developable because of water or other environmental restrictions. And vacant uses can also be just sort of treated exogenously, like we know a certain percentage of the real estate is just going to go vacant in a particular area.